What happens when a nation that once relied on imported Soviet fighters starts building its own stealth jets? In barely 2 decades, China assembled a combat air arsenal stretching from the J-10 to the J-20 and beyond. Each aircraft not a symbol of prestige, but an answer to a specific operational problem no previous platform could solve. That rise begins with one domestically designed fighter that changed everything. During the late 20th century, the People's Liberation Army Air Force relied on aging MiG-21 derivatives. These older aircraft lacked modern avionics and could not contest airspace against evolving regional threats. To solve this operational bottleneck, the Aviation Industry Corporation of China developed the J-10. Its maiden flight in 1998 moved the aviation sector from licensed assembly to domestic design. Entering service in 2004, the J-10 provided a single-engine, multi-role platform capable of air-to-air interception and air-to-ground strike. Beyond immediate combat capabilities, the program built industrial independence. For the first time, domestic engineers designed and manufactured a high-performance fighter using local supply chains. The J-10 replaced obsolete airframes and validated independent manufacturing, establishing the baseline for the advanced platforms that followed. Deploying a high-performance fighter fleet required more than a single-seat aircraft. To build a reliable training pipeline and develop complex tactics, designers introduced the Tandem seat J-10S. This dual-cockpit variant allowed experienced instructors to guide new pilots, accelerating their transition to active duty. But modern combat demanded tools extending past traditional dogfighting. To protect friendly strike groups, the airframe evolved into the J-10D electronic warfare variant. This version carried a prominent dorsal spine packed with radar jamming and signal intelligence equipment. Instead of fighting with missiles alone, the J-10D focused on sensing, suppressing enemy air defenses, and jamming radar. This shift greatly improved fleet survivability in contested environments. By adapting the J-10 from a basic interceptor into a dedicated electronic warfare platform, the aviation sector proved it could modify a single airframe to solve entirely different mission challenges. While the J-10 proved China could design a single-engine fighter, securing vast airspace demanded heavy, long-range platforms. In 1996, Beijing signed a $1.5 billion contract to assemble 200 Russian Su-27SK fighters under license, designated the J-11A. But assembly was only a temporary solution. To gain complete domestic control of this heavyweight airframe, Shenyang Aircraft Corporation developed the J-11B. This variant replaced Russian subsystems with Chinese-made avionics, the Type 1493 radar, and the domestic WS-10 Taihong turbofan engine. By 2011, nearly 90% of the airframe components were manufactured locally. The heavy fighter family soon branched to serve different military branches and specialized operational missions. The Tandem seat J-11BS served as an advanced trainer, while the J-11BH and BSH variants deployed with the Navy for long-range maritime patrol. To keep this fleet capable in modern contested combat environments, engineers launched the J-11BG upgrade. This retrofit replaces older Russian-derived passive radars with a gallium nitride AESA radar. Armed with advanced PL-10 and PL-15 air-to-air missiles, the upgraded aircraft allowed the aviation sector to turn a foreign platform into a completely sovereign shield. Projecting military power past China's coastline, required two distinct solutions: sea-based aviation and dedicated coastal strike. For naval operations, the Shenyang J-15 Flying Shark was designed to master the complex environment of flight decks. First flying in 2009, this heavy fighter was modified with reinforced landing gear and arresting hooks to operate from the ski jump deck of the aircraft carrier Liaoning. The J-15 extended the fleet's defensive footprint, shifting naval defense from coastal patrol to long-range sea control. Meanwhile, land-based offensive strike relied on a different tool altogether: the Shenyang J-7 Flying Leopard. Approved for development in 1983 and first flown in 1988, the J-7 was built to fly long distances with heavy payloads, bypassing the need for multi-role fighters to carry heavy ordnance. Joining naval service in 1994 armed with YJ-8 sea-skimming missiles, and later upgraded as the J-7A, in 2004, it carried up to 9,000 kilograms of weapons. Together, the J-15 and the J-7 split the offensive mission into two separate domains, demonstrating that safeguarding sovereign territory required both carrier-borne fighters at sea and dedicated strike bombers on the coast. The Shenyang J-16, a twin-engine, tandem-seat, heavy fighter, first flew in 2012 to modernize the long-range strike mission. Unlike legacy tactical bombers, this multi-role platform was designed to fight its way through contested airspace, carrying up to 12 tons of guided ordnance while retaining full air-to-air combat capability. Powered by domestic WS-10 engines, it gave the Air Force a heavy strike asset with extensive regional reach. But surviving modern integrated air defenses required more than raw firepower. This tactical reality led to the J-16D, a dedicated electronic warfare variant that first flew in 2021 and achieved initial capability in late 2025. While the smaller J-10D offered localized electronic support, this heavy variant was built for long-range escort. Engineers removed the internal cannon to make room for specialized electronic attack suites, replacing wingtip missile rails with prominent signals intelligence pods. The J-16D shifts the mission from hitting physical targets to dominating the electromagnetic spectrum. Utilizing active electronically scanned array radar and digital radio frequency memory jammers, it suppresses enemy air defenses and blinds tracking networks. Operating this specialized platform alongside the standard J-16 creates a dual threat strike package: one heavy fighter to blind the threat and the other to destroy it. Chengdu Aircraft Corporation partnered with the Pakistan Aeronautical Complex to build a lightweight, affordable multi-role fighter. The resulting JF-17 Thunder, designated the FC-1, established a model for co-development and export diplomacy. Unlike China's domestic fighter lines, the JF-17 was designed from the beginning for the international market and has never entered service with the Chinese military. Instead, it offers a budget-friendly option for nations looking to modernize their air arms. By delivering these aircraft to countries including Myanmar, Nigeria, and Azerbaijan, the Chinese aerospace system translates accessibility into strategic reach. This co-development model builds long-term defense dependencies, extending China's aerospace footprint far beyond its own borders. On January 11, 2011, as United States Defense Secretary Robert Gates met with Chinese officials in Beijing, a twin-engine aircraft taxied onto the runway at the Chengdu Aerospace Facility. At 12:50 p.m., the prototype accelerated and lifted into the air, accompanied by a J-10 chase plane for its 18-minute flight. This platform bypassed traditional radar using a blended wing body frame, diverterless, supersonic inlets, and internal weapon bays. It was engineered specifically to penetrate highly contested airspace and conduct long-range air intercept missions. By putting a fifth-generation stealth fighter into the sky, the aviation sector moved beyond local territorial defense, establishing a long-range force designed to challenge regional air superiority. Refining the initial design into a mature, mass-produced fleet led to the J-20A, carrying a raised dorsal hump and domestic WS-15 engines. This variant gave the Air Force true super cruise capability, but fifth-generation warfare proved to be a data processing challenge, easily overwhelming a single pilot. Chengdu solved this workload bottleneck by developing the tandem seat J-20S. First flying in 2021, the two-seat aircraft places a mission systems officer in the rear cockpit. This crew member manages electronic warfare, processes sensor data, and commands cooperative drone swarms, turning the stealth fighter into a flying command post. The Aviation Industry Corporation of China is already designing the next generation. The twin-engine J-35 project moves stealth technology to the sea, addressing the complex requirements of carrier-borne aviation. Further out, concepts like the Baidi B-type under the Nantianmen project suggest how future strike missions might unfold. This optionally manned design explores hypersonic speeds and autonomous decision-making. While these platforms remain in development, they reveal where Chinese aerospace priorities are heading. The focus has moved from catching up with global standards to defining the parameters of tomorrow's air combat. China is no longer chasing the future of military aviation. They are actively defining it. As the global balance of aerial power shifts, we face a new reality. If uncontested skies are history, who will command the airspace of tomorrow? Join the discussion below.